In 1933, Swiss astronomer Fritz Zwicky was studying a massive group of galaxies known as the Coma Cluster. But something seemed off. The galaxies were moving way too fast. According to the laws of gravity, galaxies spinning that fast should have been flung apart in every direction, and yet they stayed put, moving steadily, as if something invisible was holding them together. Zwicky thought something must be pulling on these galaxies, but no matter how deeply he looked through the telescope, he saw nothing. So, could there be some kind of invisible mass out there? Zwicky named this mysterious substance Dunkle Materie, German for dark matter. His idea didn't get much attention at the time, but 40 years later, in the 1970s, American astronomer Vera Rubin was studying how spiral galaxies rotate. Normally, if most of the mass is concentrated at the center, like in our solar system, then the farther out a star is, the slower it should spin. But Rubin saw something completely different. Stars at the edge of the galaxy were orbiting just as fast as the ones near the center. That could only mean one thing. There had to be an enormous amount of unseen mass surrounding the entire galaxy. At that point, scientists could no longer look away. There was something unseen out there, hidden in the dark. Zwicky's long-overlooked claim was finally getting attention from the scientific community. According to Einstein's general theory of relativity, strong gravity warps the fabric of space and bends the path of light along with it. This is known as gravitational lensing. Zwicky predicted that if dark matter surrounded galaxy clusters, gravitational lensing should appear there, but it was never observed during his lifetime. Then, in 1979, American astronomer Dennis Walsh and his team observed this strange phenomenon for the first time. They were observing a quasar. Quasars are among the brightest objects in the universe, powered by supermassive black holes. But oddly, what looked like two quasars turned out to be just one, seen twice. The quasar's light had been bent by the gravity of a massive galaxy sitting between it and Earth. It was the first naturally observed example of gravitational lensing. This not only confirmed Einstein's theory, it also revealed that without dark matter, such extreme bending of light couldn't be explained. Since then, thousands of gravitational lenses have been found, making the case for dark matter stronger and stronger. Scientists began to wonder, could dark matter be shaping not just individual galaxies, but the entire universe? Since the 1970s, astronomers have measured the positions of countless galaxies to create a 3D map of the universe. They found that galaxies aren't just scattered randomly. They form a vast web-like structure known as the cosmic web. Dark matter has a tendency to clump together even more than normal matter. These clumps act as gravitational anchors, pulling in matter and forming enormous filaments across space. In contrast, regions with little dark matter have weaker gravity, so matter doesn't gather there, leaving behind vast empty zones called voids. In other words, the entire universe is built upon an invisible skeleton of dark matter, where filaments and voids are connected to form a colossal cosmic structure. NASA's WMAP mission in 2003 and ESA's Planck mission in 2013 made precise measurements of the universe's matter and energy, revealing a staggering fact. Only 5% of the universe is made of matter we can actually see. So what could possibly make up the remaining 95%? We perceive the world through light, but dark matter doesn't interact with light at all. It doesn't respond to any electromagnetic radiation we know of, which means we can't see it and we can't touch it. And yet, it's clearly doing something, because gravity still applies. The force is real. Over the years, scientists have proposed countless theories about what dark matter might be. Some suggest WIMPs, weakly interacting massive particles that barely react with normal matter, but still feel gravity. Others propose axions, ultra-light particles that might convert into light in the presence of strong magnetic fields. And then there are sterile neutrinos, heavier than ordinary neutrinos and expected to interact only through gravity. Research labs around the world have built detectors, run experiments, and searched relentlessly, but so far no one has found definitive proof. In addition, this invisible 95% isn't even all dark matter. According to scientists, dark matter makes up about 27% of the universe. The rest, an astonishing 68%, is something else entirely: dark energy. Dark energy is yet another unknown, introduced only to explain why the expansion of the universe is speeding up over time. In other words, we don't fully understand even the visible 5%. And as for the other 95%, we haven't even caught the faintest trace of it. The universe we once thought was empty may actually be full. And here we are, tucked away in a quiet corner of the cosmos, unable to see or feel any of it, simply coexisting with the unknown, as if the universe itself decided, we don't need to know that, not yet. But we've always found a way to seek the answers, because even if we can't see them, those unknowns are still out there,